Alright guys, welcome back. Today we're going to move on to powers in direct proportion. Yesterday we talked about the direct proportion between x and y. Today we're going to push it a little bit further. We're not going to only compare x and y, we're also going to compare y and x to the power of n. Okay, so you're not only required to have x to the power 1, for example. You can have x to the power 2, x to the power 3, x to the power 4, and 5, and so on. And you can even be x to the power 1 over 2, which is square root x. Okay, so we are really talking about the power, all the different powers of x in this case. Okay, so in that case, we are actually comparing y and x to the power n instead of just x. The only thing that we need to notice is n cannot be equal to 0. Okay, because if you have n equals to 0, you're going to have x to the power of n equals to x to the power of 0. That gives us 1. Right? Anything to the power of 0 will give us 1. You're basically comparing y and 1, which one is not a variable. Okay? In this case, the k is still called the proportionality constant. Our notation is pretty much the same, except you're not comparing y and x anymore. You're comparing y and x to the power of potentially different powers of n. So this is a big list that you saw yesterday. The green color-coded ones are the ones that we talked about already. Those are the direct proportions between y and pure x. Okay, but today we're going to look at the blue ones. The blue ones, as you notice, they are quite close to the direct proportion. We can actually still call them direct proportion, but we are talking about direct proportions between y and the powers of x. Okay, so for example, the first one over here, the first blue one, you see that I actually have y being proportional to x squared. In that case, my k is actually equal to 3. So that one's easy. The second one, I'm actually comparing y and this power of x. This is square root x. You can actually express this as y being proportional to x to the power 1 over 2. Okay, so that's a sort of power of x. And in either case, my k is equal to 1. So we got the last one. This one is a little bit tricky because if you want to compare y with some sort of x, you have to do a little bit of manipulation over here. So y, if you take the third root, you're going to take the third root of everything over here. So the third root of 4x, if you break that down, that's going to give us y equals to the third root of 4 times the third root of x. Okay, let's write that as, sure, third root of x, or you can write it as x to the power 1 over 3. And you can basically say that, you know what, my y is proportional to the third root of x. In that case, my k, instead of being 4, as you probably see over here, instead of being that, it's actually the third root of 4. That's our k, okay? Because this over here shows our k over here. Moving on to examples, I'm going to show you 4 examples today. Start with the first one. So we consider y equals to x to the power 4. We want to find two things. We want to state the two variables that are directly proportional, and the second thing is going to find k. The first thing, we're going to state the two variables. So guys, it's not the direct proportions between x and y anymore. In this case, I hope you can see that it's actually the direct proportion between y and x to the power 4. Okay, so that's actually our first answer, pretty sure. And as you can see, we can write the equation as y equals to 1 over 5 x to the power 4. And it's pretty obvious that this is just our k. In this case, our k is equal to 1 over 5. So that's it for this question. Alright, the second one, you do a little plotting. On the test, I'll try to give you a nice grid so that it doesn't take you a lot of effort to graph like this. We're going to compare y against x squared though. Okay, so be a little bit careful. So your y-axis is still y. Your x-axis, instead of comparing that with x, we are using x squared. Okay, so it is also a good idea to write a little x squared on top of your table that they give it to you. If your x is equal to 2, then your x squared is going to give you 4. If your x is 4, x squared is 16, 36. Okay, so we can go ahead and plot it. If your x squared is equal to 4, let's find 4. Okay, this is our 4. Your y is equal to 6, so we got a point over here. X is equal to 16, then y is equal to 24. Here. Finally, when x squared equals to 36, your y is equal to 54. Okay, so if you do it correctly, you will realize that I'm not only arriving at a straight line, not only that, but also the straight line is passing through the origin. That is exactly why we are having direct proportion over here. As we mentioned yesterday in the previous lesson, you need to have two things. We need to have straight line, and second of all, we need to have the straight line through the origin. Since we're able to achieve both of them, we are actually good to go. Part B. So let's write y equals to kx squared. At the very beginning, this is what we always start with. You can plug in different points, but I think in this case, plugging in the smallest value, it will make our job the easiest. So when your y is equal to 6, my x is equal to 2. That means my x squared is equal to 4. Right, so 4 times k going to give me 6. My k is going to be equal to 3 over 2. But that's not the answer. Our answer should be an equation representing the relationship between x and y. So y is equal to 3 over 2 x squared. And that's it for this question. Question number 3, pretty much similar question that you saw yesterday, except you're dealing with powers of x, in this case d. Let's go for it. Part A, let's look at the question. If we have t equals to 100, then d is equal to 2. So let's let t equals to k d squared And we have 100 equals to k times d squared is 4. Okay, 2 squared is equal to 4. So you can solve for k. K is equal to 25. And that will apply to both a and b. So we're going to use that towards both a and b. All right, part a, we're going to find our t. D is equal to 3. So 25 times 3 squared, which is 9. And we're going to get 225 for our t. And that's part A. Part B, we get to use exactly the same equation, except in this case, instead of plugging in d, we're going to plug in t. Okay, so t is equal to 200. 200 is equal to 25 times d squared. We're going to solve for d squared. Notice that in this case, they mentioned that d is greater than 0, so we won't have plus or minus in this case, despite the fact that we have d squared. Okay, so when we divide that through, we get a equal to d squared. Again, when we square root, we don't need to worry about the minus case because our d is greater than 0. So we'll have d is equal to square root 8. You can leave it like that, or you can write it as 2 root 2. And that's our answer for this question. Last question of the day. This is a word problem. The power required to drive a motorboat is directly proportional to the cube of the speed. Here's a new unit over here. What is HP? 80 HP. HP actually stands for horsepower. It basically represents how much power is needed in order to drive the motorboat. So 80 horsepower represents the amount of power, and 20 kilometers per hour represents the speed. Okay, but we're actually having the direct proportion relationship between the power and the cubed of the speed. Okay, so we'll worry about that later. And we want to find out how much power is needed in order to drive a boat at 30 kilometers per hour. Okay, so let's get going. First of all, let's write an equation. P is equal to, if that's directly proportional to the cube of the speed, you will write P is equal to k times velocity to the power 3. Okay, let's name that as P, as power, and V as velocity over here. Okay, so P equals to kV to the power 3. Let's plug in the values given. 80 horsepower, that represents the power. K times V, in this case, is 20 to the power of 3. We're going to get k times 8,000 equals to 80. In this case, k is equal to 1 over 100. That tells us that the relationship between the power and the cube of the velocity is equal to P equals to V cubed divided by 100. Okay, so now we can use that. P is equal to V cubed divided by 100, but in this case, our V becomes a 30. So 30 cubed divided by 100, and that's going to give us 27,000 over 100, and that's 270 horsepower. We might not have a lot of idea about what this horsepower means. Just to give you an idea, normally for a normal car, in order for us to drive with 100 kilometers per hour, that's super fast. Okay, you get a ticket if you drive that fast. In order for you to drive that, we only need 10 to 20 horsepower in order to drive that fast on the road with a car. But for boats, in order for you to drive with only 30 kilometers per hour, you actually need a lot of power, which kind of makes sense because we're dealing with waters, which has something to do with frictions and buoyancy and stuff like that. So yeah, and plus the fact that the boat is probably a lot more heavier than a normal car. So that kind of gives you an idea what a horsepower is. Okay, so otherwise that's pretty much it for this question. And that's pretty much it for today. I'll see you guys in the next lesson. Peace.